Welcome everyone. For today's prep, we're going to finish this example that we started in class. So this one trig substitution we started. And in the process here, we're going to see how once we have our antiderivative in terms of trig functions, how do we actually convert back to x terms? All right, so the function we had here was 1 over x squared times the square root of 4 plus x squared. And we first chose our substitution based on that square root term. So it was this a squared plus x squared form. So we let x equal 2 tangent theta. And how we figured out the constant in front is we just took the number that's under the square root and we did the square root. All right, so then once we had our substitution, then we calculated our differential. So the derivative of tangent is secant squared. So we get 2 secant squared there for our differential. And then we know how the square root term switches over as well. So that square root term becomes the opposite trig function based on that trig identity. So we know tangent squared and secant squared are related to each other. So we let x equal tangent. So the square root term becomes the opposite. So in this case, secant. So then we plugged all these pieces in, simplified it down, and this is where we ended up. The integral of secant divided by 4 tangent squared. So now we have a trig integral, and we have our powers of secant and tangent. So we have a few options at our disposal. We could try u-substitution. So our kind of 2 standard substitutions that we look for with a power of secant or tan is we let u equal secant, or we let u equal tangent. And how we can kind of tell if they're going to work or not based on the differentials. So if we calculate the differential for secant, we get secant times tan. And if we calculate the differential for tangent, we get secant squared. So if we kind of look at the differentials here, in order for this substitution to work, we need 1 copy of secant and we need 1 copy of tangent that we can kind of factor out of here and put next to our differential, which doesn't look like we're going to have that actually. And then for the other substitution, it looks like we're going to need 2 copies of secant that we'll need to kind of peel off and move next to our differential. We only have 1 copy. So immediately, these don't look like they're going to work. Maybe if we tried something fancy, try to get clever, we can make them work. But on the surface, it doesn't look like these are going to work. So we want to go to one of our other strategies. And one of our other strategies for these powers of secant and tan is to try and convert these into sines and cosines. So let's try that approach. So I'm going to break this function apart a little bit. So first of all, we're dividing by 4. So I'm just going to separate that off as just 1 over 4. Let's rewrite the secant term. So secant is 1 over cosine. So that's what we're rewriting here. And then let's rewrite the tangent squared here. So we know tangent is sine over cosine. Since we're dividing by tangent, this is just the reciprocal. So this will be cosine squared over sine squared. So normally tangent is sine over cosine, but because we're dividing by the tangent, it's the reciprocal. And then we've got our d theta at the end. So this first one, this was our secant term, and this was our 1 over tangent squared term. All right, so now brand new trig integral to look at, and now we get a little bit more canceling. So we've got some cosine terms that cancel off. So this simplifies to just the integral of 1 over 4 times cosine theta over sine squared theta. Okay. And now what do we have? Well, we have powers of sine and cosine, and we've got an odd power of cosine. So, Yahtzee, we're ready to go. So once we have our odd power, we can now go through our regular strategy. So we're going to peel off that odd power, put it next to our differential. We've got our 1 over sine squared theta times cosine theta d theta. And again, we're going to save this for a u-substitution. And the goal is, in order to get ourselves ready for that u-substitution, we got to make all the terms here into the opposite trig function. So since we're saving cosine, we want to make all these terms sine, which they already are. So if there were still some cosines here, we'd have to convert those over. But we got our one cosine over here. Everything's ready in terms of sine. So now we can do our u-sub. So we're going to let u equal sine theta. And then our differential will be cosine theta d theta. So the derivative of sine is cosine. Again, remember, the term that we're peeling off, we're kind of saving that for our differential. So then our choice for u is just going to be the odd trig or the opposite trig function. So since we're saving a cosine, that means we're letting u equal sine. So if we actually do the substitution, we end up with the integral 1 over 4 times 1 over u squared du. And now this is just a polynomial. This is just a power function. We can get the antiderivative. So the antiderivative, we're going to have the 1 over 4, and then let's do our power rule. And we're really thinking of that 1 over u squared as u to the minus 2. So we add 1 to the exponent, take the new exponent, flip it, put it in front, and we have our plus c on at the end. And we could simplify this down. So we get negative 1 over 4 times 1 over u. All right, so this is our u antiderivative. So we're done with the integration process, but now we just have to convert back. And in this case, we've done a few substitutions. So we had our original trig substitution at the beginning, but we also had this u substitution later on. So we kind of have to backtrack and go back through all the different substitutions we did. So the first thing is, let's rewrite based on our u substitution here. So we'll have our negative 1 over 4, and then instead of 1 over u, we'll have 1 over sine. And then we've got our plus c. And now we could leave this as just 1 over sine, perfectly fine. If we wanted to, we could convert that into cosecant, so that's another option. But we still got to get this back to x. And if we look at our original substitution here, original trig sub, we know how we're going to convert this back to x. But none of the pieces here have a sign in it. So we got to do a little bit of geometry to help us figure out what sine of theta is based on, these things. So this is where a right triangle is going to come in handy. So if our antiderivative had only secants and tangents in it, then we could just use this info from earlier. but because we have this other trig function in it that wasn't immediately in our substitution here, we got to do a little bit of this geometry. So let's go back and see how we're converting back to x. So in a lot of the examples or a lot of the problems that we do, sometimes we have to use this right triangle to help us. So theta here is kind of the angle we've been looking at as part of our original substitution. We've got our right angle, and for a right triangle, the hypotenuse is the side that's opposite the right angle, and then we've got the opposite side that's opposite to this angle theta, and then we've got the adjacent side, the side that's next to theta. All right, so all of our trig functions can be related to the sides of a right triangle. So let's remember what these are. So there's sine of theta, and it's the opposite function or opposite side over the hypotenuse. Cosine theta is the adjacent side over the hypotenuse. And then once you know what sine and cosine are, you can probably just figure out then what the other ones are based on, you know, the trig identity. So how is tangent related to sine and cosine? So let's see, tangent theta, as remembering, is sine over cosine. So if we were to think of that in terms of our trig functions, it'll be the opposite side over the adjacent side. So the hypotenuses would cancel out from our sine over cosine. And then similar for cosecant theta and secant theta and cotangent theta. Now, these three other trig functions, these are just the reciprocals. So secant is just the reciprocal of sine. So we can just flip this fraction, flip it around. So cosecant would be the hypotenuse over the opposite side. Same thing, cosine is the reciprocal of secant, or secant is the reciprocal of cosine, however you want to think of it. So this would be hypotenuse over the adjacent side. And cotangent is just the reciprocal of tangent, so it's just adjacent over opposite. All right, so how we're gonna use this, again, this is just reciprocal too. We're gonna use our original trig substitution to figure out what the sides of our triangle look like. And then once we know the sides of the triangle, we can find any of the missing trig functions that show up in our antiderivative. So let's try it out. All right, so let's look at our trig sub. All right, that original trig sub, x equals 2 tangent theta. So let's get our right triangle. Here's theta. And we know that x was equal to 2 tangent theta. So let's solve that equation for tangent theta. So divide both sides by 2. All right, so if we remember what tangent theta is the opposite side over the adjacent side. So if we kind of match up our two fractions here, we see that the opposite side has length x, so we can label that. And the adjacent side has length 2. Okay. Well, then what's the length of the missing side? Well, we could use the Pythagorean theorem. And if we use the Pythagorean theorem, what we're going to see is that the missing side is just the square root term that we had kind of started with. All right, so once we get all three sides of our triangle, now we can figure out any missing trig functions that we need to kind of convert back for. So we need to know what sine is. So if we look at our right triangle, sine of theta is the opposite side over the hypotenuse. So opposite over hypotenuse. So if we fill that in, it'll be x over square root 4 plus x squared. And that means 1 over sine, the reciprocal, is just this going to be flipped around. So it'll be square root 4 plus x squared over x. And so we finally fill that in. So we have our negative 1 over 4, and then we've got our square root 4 plus x squared all over x, and then our plus c. So there is our antiderivative. All right, so this one shows once we get our trig integral and we go through the integration process, how do we get back to x here? So we'll be practicing some more of these in class. So we'll see you then. Bye-bye.